Welcome to the Siemens process instrumentation video on using mag meters in zero upstream and zero downstream piping applications. My name is Jack Roushey and I am the product manager for the Siemens electromagnetic flow meters. One of the questions I get asked all the time is, what options are available if I don't have the ideal piping configuration for my mag meters? First, let's take a moment to review the measurement principle that is used in the electromagnetic flow meter. Simply put, when a conductive material flows perpendicular to a magnetic field, it will induce a voltage that is commensurate with velocity. The higher the velocity, the higher the voltage. By knowing the velocity, we can then determine the volumetric flow rate through a fixed diameter pipe. As long as the minimum conductivity threshold is met, the technology is immune to changes in the conductive property of the fluid being measured. This makes the mag meter a very reliable and universally accepted flow measurement technology. Of course, we always want to encourage people to follow the best practices when it comes to installing their flow meters, and mag meters are no exception. In order to assure the stated accuracy of the meter, you want 5 diameters of the same diameter straight run pipe upstream from the sensor's measuring electrode and 3 diameters downstream. The measuring electrode is centered in the sensor tube, so include the sensor tube lay length as part of your calculation. However, we realize that these conditions don't always exist, so we had the Siemens Mag 5100W and Mag 8000 mag meters independently tested to see what we could offer as an alternative solution to those customers who don't have the ideal piping available. First, let me state without exception that we need the pipe to be full. Mag meters measure velocity and calculate the volumetric flow rate based on the presumption of a full pipe. There are a couple of basic rules that I like to follow when installing a flow meter. 1. If you need to mount the meter in a vertical run, always try to have the flow going up through the meter. If you are mounting the meter in a horizontal pipe, it's usually best to have the meter mounted in a location where the piping downstream of the flow sensor eventually extends above the meter. By having the flow go up after the mag meter, you usually will keep the area where the mag meter is mounted as a full pipe. 2. We also never recommend that the meter be mounted where the flow is vertical down. Again, because of the higher likelihood that the pipe will not remain full during measurement. Once the full pipe is assured, here is what we did to confirm our meter's performance. A series of tests were conducted by a globally accredited agency, which confirmed that the Mag 5100W and Mag 8000 are capable of 2% accuracy, even in non-standard configurations with an insufficient straight run of pipe. First, a reference test was conducted by installing the Mag 5100W and Mag 8000 as recommended by Siemens for the best possible performance, with 5 diameters upstream and 3 diameters downstream straight run pipe from the sensor's electrodes. The meters were then tested in various configurations which do not meet the recommended installation conditions. These included mounting a fully open shutoff valve directly in front of the meter, and also various configurations with elbows and T's creating 90-degree turns before and after the meter. Each test configuration was run 4 times in order to confirm consistent results. As the results were consistent, the independent agency then certified the Mag 5100W and Mag 8000 with these installation variations for an accuracy of plus or minus 2%. Even with 0 diameters upstream and downstream of straight run pipes. This is not to say that we are okay with all 0 upstream, 0 downstream configurations. Most notably, you will still need to follow recommended guidelines when control valves are involved. Let me explain. A shutoff valve is assumed to be either fully open when the flow is moving or fully closed when no flow is desired. This is the reason we can confirm 2% accuracy even if the shutoff valve is mounted directly before or after the mag meter. Control valves are a different story. Because they come in many configurations, and because they can be set in partially open configurations, there is no way to calculate the effect on the flow profile based on these almost infinite geometries. As such, the only alternative is to provide a straight run of pipe between the valve and the mag meter to create a predictable flow profile through the meter to assure performance levels that we can rely on. This is why we recommend 10 diameters upstream and 5 diameters downstream when control valves are involved. For more information on our ability to measure accurately in zero upstream and/or downstream configurations, we have developed a 2-page brochure that describes our zero upstream, zero downstream capabilities. So, in conclusion, the key points to remember are: 1. Mag meters always require that the pipe be full in order to measure accurately. Make sure your installation provides a full pipe condition in the sensor. 2. We always recommend following the ideal installation guidelines set forward by Siemens to assure the best possible performance of your mag flow meter. 3. Siemens has received certification from an independent agency that our MAG 5100W and MAG 8000 sensors can perform at 2% accuracy levels even when zero upstream and/or zero downstream piping conditions exist. 4. The certification we received includes having T's, elbows, or even shutoff valves immediately upstream or downstream of the flow sensor. 5. The certification does not include mounting a control valve that may be only partially open in anything other than our recommended upstream and downstream guidelines. Siemens offers our customers an independently certified solution when optimum piping design is not available. I hope you have found this video on the zero upstream, zero downstream installation of the MAG 5100W and MAG 8000 products to be useful. Thank you very much for listening.